Hi everyone. We are going to start off with the fourth lecture rather on power plants. We're going to talk about more of nuclear power plants today. Before I start, please do subscribe to my channel Waves Physics Lectures. As a matter of fact, I'm also uploading lectures on other topics like XRD basics and all, and with due time we are going to learn a lot of physics over there. But this lecture series is basically a part of the online classes that I'm conducting for the institute. So in lecture 4 we are going to study about nuclear power plant. Before we proceed to nuclear power plant, let's just finish off with the thermal power plant, which we have done in the lecture 3, and please try to remember or recall lecture 3 a bit. And here we are going to just talk about the thermal power plants. Okay, so thermal power plants, we're just going to talk about the advantages right now. There are a few points that you should remember. This probably might be a 1-mark question. You don't need to remember or write down every point in detail, but definitely you should know that. Okay, so a thermal power plant is economical for low cost because the initial cost is very low, and it's better than the other generating plants in terms of the cost that is required. Now the land required is less than the hydropower plant. The hydropower plant is also a quite popular power plant, but the land requirement is much less in case of the thermal power plants. Now since coal is the main fuel and it's not renewable, the cost is actually cheap compared to petrol and diesel. So it's basically very much economical, but that also comes up as a disadvantage, which I'm going to tell in the next slide. Maintenance is easier, definitely, okay, but you need to definitely dispose of the ash that is procured from the coal during the process. So thermal power plant can be installed in any of the locations, okay, where you basically have the transportation and the water is enormous. More water is there, so it should be basically in a river side, probably out of the city. That is what was discussed in the last lecture. Now, what are its disadvantages? Now, if you look into the disadvantages, the running cost for a thermal power station is comparatively high. So, due to fuel maintenance, etc. So, in the last slide, I did say that it's economical, and you might say that okay, that's basically not matching up with what I said in the last lecture. But that comparison was compared to other kind of power plants that are being used, let's say for a nuclear power plant and so on. But in general, if you look into it, compared to a hydel power plant, the cost might be a bit high. The large amount of smoke basically causes a lot of air pollution. That's why I said it should be far away from the city, and the thermal power station is also very much responsible for global warming. Okay, that's one of the proved facts. Now the heat, the water that comes from the thermal power plant has an adverse effect on the aquatic lives in the water and disturbs the ecology, and that's true because we are using a large water source, and if we are having a power plant dumping a lot of waste there and so on, we are basically affecting the life because we are using up the water there, and the efficiency obviously is a bit less, 30%, which is a bit less for our liking. Okay, so that ends our thermal power plant, and today what we are going to do is learn about nuclear power plants. So but before we start with the nuclear power plants, I hope all of us know that what is basically nuclear physics dealing with. Nuclear physics, if you have learnt it before, you must have come across the terms like fission and fusion, right? So these are some of the terms that you should know. And if you consider the atom, if you basically consider the atom, the nucleus is somewhere at the center, and whatever reaction takes place is at the nuclei, right? We are not talking anything involved with electrons, we are talking about the reactions involved with protons and neutrons, and obviously the range of energy that we talk about in nuclear physics is 1 million electron volt, okay, or in terms of million electron volt might be one or bit more. Okay, so if we just look into the top 5 nuclear countries which are generating maximum nuclear power, and this is as per the 2017 census. Well, United States and France generates maximum power, not in terms of percentage but in terms of the electricity that usually they generate. So France, you can say, basically supplies 71.5% of the entire electricity through nuclear power, whereas the United States actually supplies percentage of 19.8, although the requirement of France is less compared to United States. As far as China is concerned, in terms of percentage, it's not very ahead of India, because in India it's 3.22%, which I'm going to say in the next slide. Next is Russia, whose net use from nuclear power is 18.4, and South Korea it's 26.6%. So if we just look into some stats from India in nuclear power, India is basically nuclear power is the fifth largest source of electricity. The first top four are basically coal, gas, hydroelectricity, and wind power. I think we have already discussed this in our unit 1, but we'll just revise this. And please remember, wind power is something which is renewable in nature. Definitely we are interested in having more of solar power, but that usually doesn't come in the first top 5. Okay. Now in March 2018, so as per March 2018, we have around 22 power stations, nuclear reactors in operation, and 7 nuclear power plants. Okay, so we do have number of reactors in one power plant itself. Okay, so we do have 7 nuclear power plants throughout the country, and they are installed in a lot of places. I think I've already given you a detail of the map in the previous class. The total installed capacity is 6780 megawatt. Okay, so just remember this value, because that's actually important. And the nuclear power produced a total of 35 terawatt hour till now. Okay, and then the supply of 3.22% of Indian electricity was from nuclear power in the 2017, slightly lesser than China. 7 more reactors are under construction. Okay, and we surely hope that in the coming years we can expect that this percentage will definitely go up. Okay, this percentage will definitely go up in the coming years. So if we talk about the basics of a nuclear power plant, it is nothing different. We have already discussed about Rankine cycle, and it actually works on a similar principle. The type of power plant that use the process of nuclear fission to generate the electricity. So nuclear fission is used to generate electricity. Nuclear fission, I think you know this, but anyway I'm going to just discuss the basics in the next slide. Now the heat generated, we use the nuclear reactors in combination with Rankine cycle. So please remember this, the principle of the power plant remains the same, and the heat generated by the reactor will basically convert water into steam. So if you remember, in our thermal power plant we use coal to generate a lot of heat, and that heat is actually used to generate the steam. Here also we are using nuclear power to generate the heat, and that will generate the steam. Now this steam will again spin the turbine, and the generator will actually generate the electricity, right? So in case of the generator, I hope all of you remember we used an alternator. Okay, so these things should be clear to you, because we have done a long lecture on this in the last session. So the nuclear power provides the world with around 11%. Now if you look into the entire world, around 11% of the world's electricity is provided by nuclear power, and the largest producers have been United States and France. I know you might be thinking about the previous slide where 26.6% is for South Korea, but that's actually in a comparative with the country. The amount of electricity that is generated by nuclear power is maximum in France and United States. Okay, but if you look into the country, as South Korea is a smaller country compared to United States and France, and obviously the requirement is lesser. Okay, so the amount of power generated is more for United States and France. So the nuclear power plant basically works in similar to coal fired power plants. So obviously it follows the Rankine cycle, nothing new there, but they do require a safety measure. So you know that nuclear power, generating a nuclear power is actually very dangerous. There has been a lot of history with this, and there has been a lot of accidents also, which has proved to be very much fatal, and the places are rendered unusable, for example the Chernobyl disaster and so on. So the nuclear power plant definitely requires a lot of safety measures, so that means the build-up and the cost might be higher. Okay, and it has vastly different properties from coal or other fossil fuels. Okay, so the thermal power plant from the thermal power that is being generated in a nuclear power plant is by splitting of the nuclei of the atom in their reactor core, and uranium basically is the dominant choice of fuel in the world today. So you have to remember this, that uranium is the most used fuel, okay, in place of nuclear power plant. We can also use thorium, but thorium is not actually currently in use, right? So some basic ideas there. And what do you mean by nuclear fission? I think you already know. You basically have a fissionable material, mostly it's uranium 235, okay. So if you take uranium 235 and let's say you have a neutron, okay, and it basically comes and hits the target, which is the uranium 235, you are going to get 3 neutrons out there, okay. You're going to get 3 neutron, and you are going to get 2 fissionable material. That means the uranium has fissioned into 2 different materials altogether, let's say A and B, okay. There can be different materials, for example it might be a krypton, okay. So krypton and barium is something which you already know. These are some examples, and this is what is nuclear fission is all about. And if we actually want to have a fission, because these 3 neutrons will again generate another 3, and this will generate another 3, and this will generate another 3, and the total will become 9. So from 1 it becomes 3, and then it becomes 9. So this is something which is not needed, because this will actually set up a chain reaction, okay, and we don't want a chain reaction, because then we cannot control the reaction, and hence we use something which is called a nuclear reactor. So in a nuclear reactor we do have a basic uranium rod, you can say, okay. These are the uranium rods, okay, and then there is something which is called the moderator, okay. So we have the moderator here, which slows down the neutron so that it can react with the uranium rod, okay. And then we have got something which is called the control rods. The control rod, what it does is basically absorbs the excess neutron that comes in, okay. So if it generates 3 neutrons here, these 2 neutrons might be absorbed by the control rod, and only 1 neutron will be allowed to go ahead, okay, and in that way we can actually have a controlled reaction. However, we don't need to learn the detail of a nuclear reactor. Let's not take this as a part of a course, but a brief of this nuclear fission reaction would be this, okay. So the amount of electric power that is produced for each unit of thermal power gives the plant its thermal efficiency. So thermal efficiency definition remains the same. It is actually nothing but compared to the output to the amount of the power that is generated at the input. But due to this second law of thermodynamics, which deals with entropy, there is an upper limit to how efficient these plants can be. So there is always an upper limit. It cannot be 100% efficient, because there is an entropy there. There is a system of disorderness which comes into the picture, as a result of which you cannot get 100% efficiency. A typical power plant, which is nuclear power plant, will actually have a 33 to 37 power plant percentage of efficiency. But if you talk about some generation of the fourth nuclear reactors, that means it's the fourth generation of nuclear reactors with more advanced technology, the efficiency can move up to 45%, okay. Now, since I talked about second law of thermodynamics, just have a look at this. In the second law of thermodynamics states that the total entropy of a system and its surrounding can remain constant in ideal cases. So what happens is, if you are considering a nuclear reactor, you want it to remain constant, okay, the total entropy. Now if the process keeps on changing, the entropy will actually keep on changing, and the system will become more and more irreversible, which I don't want, okay. So the system is considered to be in thermodynamic equilibrium, or is undergoing a reversible process. So if it follows the second law of thermodynamics, the system will be in thermodynamic equilibrium and it will undergo a reversible process. Now in general, in all the processes that occurs, including spontaneous process, the total entropy of the system and the surrounding will keep on increasing, okay, and the process will become irreversible in the thermodynamic sense, okay, which we don't need. So we don't want the entropy to increase too much, so the efficiency definitely has to be compromised there. So the increase in the entropy accounts for the irreversibility of the natural process, okay. So so we don't want the entropy to be too much, and as a result of which it follows the second law of thermodynamics. Okay, so that's all for today. This lecture I've kept it short because we just talked about nuclear power plants. In the next class, we're going to take up with the next topic.